Welcome back to Unit 3, Section 1, Geosphere Notes. We're going to start off with Part 3 today. We're going to focus on what happens to those different layers of the Earth and what's actually happening on how our different geologic features are created. Most geologic activity on Earth occurs at what we call the plate boundaries. Okay, so as you know, as we mentioned, and you should know this from other science classes, the Earth's crust, or the lithosphere, is divided into very large plates. What we call them plates because they're flat, right? Okay, but very large land masses. Okay, the crust is divided up, and this lithosphere, these plates, sit on top of the asthenosphere. So you can see the lithosphere here, that layer, and then the asthenosphere beneath it, with that plastic or molten layer. Now it sort of acts like a lava lamp, okay? Again, not a solid, but not a liquid either. Down here, the magma gets hot, it starts to move up, it rises, it cools, and then as it cools down, it sinks back down again, creating what we call a convection current. You should be familiar with these as well, okay? But as it moves, it causes the plates on top of them to move as well. And all this movement causes things to happen on the surface of the Earth. Now there are three main types of boundaries, and again, this should be some review for you. We are going to spend time with it. You do not have that many notes to fill in, but you do want to be paying attention. The convergent boundary is the first one. Hopefully you know that the word convergent means to come together. When two things converge, they come together. So at a convergent plate boundary, you have two plates meeting each other. Divergent, I hope you know that to diverge from something means to move away from, to differentiate, and so divergent boundaries, the plates move apart. The last boundary, the transform boundary, is actually where two plates move next to each other, but they don't come together and move apart. They actually move against each other and rub against each other and cause, this is where we usually have our earthquakes happening. We're going to take a minute to look at each of these different boundaries, because this will help you out with your tectonic plate boundary if you haven't done it already. Okay, so let's go ahead and talk about divergent boundaries first. Then we'll go into the convergent boundaries, and then we'll talk a little bit more about transform boundaries. Now you guys have this, well, I like it, obviously, because I gave it to you. This really great diagram on your page, but it has examples of each of them, but I have a couple more examples to give you first. Okay, so we're going to actually see each of these a little bit more up close and personal. Alright, so let's start off with divergent boundary. This is a picture of something that should be familiar, the theory of seafloor spreading. And there's an extra video on NEO for you to look at. The theory of seafloor spreading says that the ocean, at the center of the ocean, is a ridge where magma is allowed to come up through where two plates are moving apart, and actually helps push them out. So these two plates, one on either side of the center line of the ocean, they're moving away from each other. And because they're moving away, it leaves extra space for that magma to come up. And the magma creates new rock. And as it creates new rock, it pushes out, pushes the plates away from each other, and more rock can come up and move into it. Okay? Now, this can actually happen in one of two ways. First, it could be on an ocean that already exists. Okay, so again, new ocean crust. This is a picture here from the Great Mid-Atlantic Ridge in the center of our Atlantic Ocean, because the Atlantic Ocean is actually growing. You have two plates pushing away from each other, and the Atlantic Ocean getting bigger. Okay. Another example of where a diverging plate can happen is actually underneath a continent. New convection currents are created. They start to move underneath of one continental plate, and it actually causes that continental plate to rip or rift apart, which is why it creates what we call a rift valley. Okay, you have this picture here where you can see the large sides of that valley, okay, very high. We have this low area here, and that's what we have. Basically, your continent has been ripped apart, and now you have that lower, heavier ocean crust forming. Now, this has happened before. It's how we have the Red Sea, but it's happening again also in Africa in what we call the Great Rift Valley, and you can see there's some volcanoes there. And you'll take a closer look at this as you do your tectonic plate boundary when you're looking at Google Maps. Okay, so that's divergent plates. Another thing, speaking of the Atlantic Ridge, let's go back to Iceland for a second. Oh, there we go. Up north, how did Iceland get created? Well, actually, Iceland is also the result of divergent boundary, that movement apart. This is a place where there's so much magma activity that the magma has created land. Okay, so Iceland is actually several volcanoes together, created from those plates moving apart. And you can see, this is a picture, one of my pictures from Iceland. There's a lake back here. You can see the blue water there, where it sits right on top of the divergent boundary. It's actually two different continental plates moving away from each other. You can scuba dive if you choose. It was pretty cold in August, and so my dad and I decided not to go scuba diving. We could actually scuba dive down into between the two plates. Now, this valley here there is no signage here for it, but the way it was situated on that along that lake and the way things are moving apart, I am convinced that this is definitely part of that rift happening there, of those two divergent plates. So this is a picture I took from on top of that valley. Okay, again, so Iceland is actually created from two plates moving away from each other. Also, you might want to take a second to look at the extra things, so you can see a picture of the Mid-Atlantic Ridge, or a video of Mid-Atlantic Ridge and how it's growing. After divergent boundaries, let's go ahead and talk about convergent boundaries. Now, convergent boundaries are where two plates move together. Now, a couple different things can happen here because it really depends on what plates are involved. Okay, if you have two oceanic plates coming together, one of those plates is going to actually slip below the other one. It just depends on which one goes below. Okay, this is what we call subduction. Again, this should be something that's familiar to you. You have those trenches that are there where the two plates meet. You might have heard of the Mariana Trench. That's a trench where the two plates are meeting. You can actually see it over here. Okay, again, from Google Earth, you can see how there are low areas on this bottom of the ocean, and that's actually where two continental plates are meeting. Now, as they go under, they actually sort of trap some magma between them, and that magma doesn't really have anywhere to go except for up. So that magma forces its way through to the surface, and eventually it'll go above the surface of the water. Now, because you have volcanoes sitting in the middle of the ocean, you have that new land there, and there's just ocean around it, they create what we call volcanic islands. And because they're usually connected together, there's a string. You can see here that they happen on the upper side of that trench where it goes. It's always going to be on the top plate. Okay, it creates what we see. Do you see how the circular? It's what we call an arc. So these are called volcanic island arcs. So this is how the Philippines, how Japan, a lot of different places on our Earth have been created. Okay. Another thing that could happen is called a volcanic mountain range. Now that happens when the oceanic crust meets the continental crust. Continental crust is actually thicker than oceanic crust, but it's also lighter. So oceanic crust, even though it's thin, is a lot more dense than continental crust. And so when those two plates meet, the ocean crust always goes beneath the continental crust. So again, you can see a trench forming there along the continent where the oceanic crust is being subducted below the continental crust. And it creates what we call a volcanic mountain range. Now again, your magma is trapped between the two plates. It doesn't really have anywhere to go except for up. Now those up above it is a continent, so that magma is going to form volcanoes on a continent, and they'll have volcanic island arch. This is how we have Cascade Mountains out near Mount St. or part where Mount St. Helen is. If you guys, we're going to talk about that volcanic eruption that happened in the 80s. But you can see it's going to be volcanic island or volcanic mountain ranges happen near ocean coasts because you have the ocean being subducted below the continental crust and forcing magma up. So as you do your activity, you're going to see some of that as well. The last one, when two plates move together, is what we call a folded mountain range. Now this happens when we have two continents meeting each other. The continents have nowhere to go. One of them, they don't want to give way. One of them doesn't want to go underneath the other. You have all this stuff sitting on top of them. These continents sitting on top of them. So they crash together and they crumble the crust together, and it actually looks like folds. You can see this picture from Google Earth. How it looks sort of like you would take some material and sort of shove it together on either side. So you can see the folds in there. So it's called a folded mountain range because it looks like the surface of the earth has been folded over on itself together. Okay? Like you're pinching two ends together. Okay, this is actually how we have the Himalayan mountains, the Appalachian mountains, the Swiss Alps, all those formed from continents running into each other as they move across Earth's surface. As you do your activity, this is what you should end up looking at, and you're going to come through and you're going to create a map that shows all the different things that are happening on the surface and how we get different parts. So if you have any questions on that, please let me know. Okay. Next thing we're going to talk about is how you want to do that. Basically, guys, you're going to create a key. I used blue to show new ocean crust. I used orange for the mountain range, okay, volcanic mountain ranges. Red for volcanic island arches. Brown for folded mountain ranges. Green for rift valleys. And, yep, oh, that's all of them. Okay, so if you have any questions, let me know, and we'll start from there. Okay?